Alright, let's try another one. This one I think we can do by root test again. So we look at the nth root. We got x minus 3 over n plus 1 raised to the nth root. That would give you x minus 3 all over n plus 1 raised to the 1 over n. Right? And then you can, well, of course, we've got to take the limit. The limit is n, as n goes towards infinity of x minus 3 over n plus 1 raised to the 1 over n. There's no n's on the top, so that's staying fixed. Nothing to do. We just have to figure out the nth root on the bottom. If you go on and you try the plug-in method, this will give you x minus 3 on the top because there's nothing to plug in. It would give you infinity raised to the 0, which is one of the famous indeterminate forms. So maybe we could take our time here and elaborate on that piece right there. Maybe we do a little ELN trick. So this would be the limit ELN n plus 1 raised to the 1 over n. You could take the limit through the continuous functions. This becomes e to the limit of, you can bring this down, ln of n plus 1 over n. Now here you try the plug-in method. That gives you infinity to infinity. That's perfect because then you can use L'Hopital, so it becomes e 1 over n plus 1 over 1. So this becomes 0, so it becomes e to the 0. So that becomes e to the 0, which is equal to 1. So that becomes x minus 3 all over 1. So that limit becomes x minus 3. This tells you that the original series behaves a lot like, let me see if I have another one on the next slide. Yeah, so this tells you, I used a different pen. This tells you that this series, x minus 3 raised to the n over n plus 1, behaves a lot like x minus 3 to the n, the geometric version of it. So this will clearly converge. Here's what we know it will converge. If x minus 3 is less than 1, it will diverge if x minus 3 is greater than 1, and no call if x minus 3 is equal to 1. We'd have to go back to the original one and check that, because the geometric series test, or the root test, is inconclusive when when that limit is equal to 1. So this has to be handled separately. Alright, let's check what does this mean. Let's see, let's work this out. So you have x minus 3 stuck between -1 and 1. So you have that x is stuck between 4 and 2. So then you have to check the endpoints. The endpoints will be in 2 and 4. For x equals to 2, that's where you get 1, and 4 is the other one where you get 1. For x equals 2, so we check x equals 2. That would give you -1 to the n all over n plus 1. Winner, winner, chicken dinner. That converges by the alternating series test, because you got alternating, you got decreasing going to 0. For sure. Now we check the other one, x equals 4. For that we get 1 to the n all over n plus 1, which is just 1 over n plus 1. That diverges because it's a lot like the harmonic series, or you can use limit comparison test, or a bunch of them. Clearly that divergence, and it gives us our answer. We know from 2 to 4 we have convergence here. We know at 2 we also have convergence, and we know at 4 we do not, so you leave that blank. So the interval of convergence is all your x's between 4 and 2, including 2. Yippee-ki-yay, that was easy, right? Alright, come back and we'll do another one. Peace.